Hey guys, we're on day 3 of our geometry unit, and you should be on page 844. And I just want to review really quick a couple terms. We talked about a polygon being a closed shape, which means all the endpoints meet, and it has 3 or more lines. We talked about a hexagon having 6 sides and 6 angles, a pentagon having 5 sides and 5 angles, an octagon having 8 sides and 8 angles, and we talked about what a quadrilateral is. It's a type of polygon, but it only has 4 sides and 4 angles. If it's a quadrilateral, it will never have more than 4 sides and 4 angles. So if you look at the bottom of page 844, that first shape, if you look at number 10, the very first shape, that's not a closed shape. And those lines cross. So that is definitely not a hexagon. The next shape only has, let's see, 1, 2, 3, 4, 5. That's a pentagon, so that's not a hexagon. So let's look at the next one. That shape has 1, 2, 3, 4, 5, 6 sides and 6 angles, so that is a hexagon. So C is the correct answer for that. We're going to move kind of quick today because we are going to talk just for a little bit about triangles. And if you go to page 846, you're going to see at the top, it says a triangle with one right angle is called a right triangle. So on my paper, I have a right triangle because this angle right here forms a perfect square, and we know that means it's a right triangle. Now, sometimes your triangles will have at least one angle that's greater than. Just like we talked about angles that are greater than, these are angles that are greater than 90 or a right angle, but it's a triangle. It forms a triangle. Here's your angle that's greater than a right angle. These two aren't, right? Those two are smaller, but this one is. And then if you look down here, this is an example of a triangle that all 3 angles are less than a right triangle, which means the space from here to here is a lot smaller than from here to here. Same for this one and the same for this one. Okay? But the one you really need to remember is the right triangle. And then we just need to be able to say, okay, well, this is greater than a right triangle or smaller than a right triangle. So that's what we're really going to look at when we're talking about the triangles. So go to page 847 in your math workbook. Remember, just pause me if you need to go get it. But we're on number 11, and we're going to compare the angles of each triangle, okay? So let's look at number 11. We have to circle which is the correct description. Now, is that triangle, is that a right angle, or does that have one angle greater than a right angle? Well, as I look at that, I might have to turn my head a little bit so I could look at it, but if this is what I'm looking at, which is what you're looking at, it looks kind of like this, I think. Right? This is greater than a right angle. So you should have marked one angle is greater. Now look at number 12, okay? Number 12, I see right away that perfect square formed in the corner. Do you see it? So that is a right triangle because it forms a perfect square. Number 13, those angles are all less than a right angle or greater. Well, those look pretty small. So I can tell just by looking that those are less than. So 3 angles are less than a right angle. And let's do one more together, number 14. Number 14 says one right angle or one angle is greater than a right angle. Well, look at that top angle on number 14, the top of that triangle. That's bigger than a right triangle. So we would want to circle one angle is greater than a right angle. Okay? So, that's really all that we need to learn from that section. Go ahead. We're going to keep moving, and I know we're going kind of fast, but that's really the only thing in that section that I feel is important for you to be able to do. So let's look at quadrilaterals. Now, we already know a quadrilateral is a closed shape that has to have 4 sides and 4 angles, right? Now, quadrilaterals also have sides that are parallel. Parallel are 2 lines that run like this. So if I did this, these lines are parallel to each other. Oops, there you go. Parallel. They never cross. They never touch. Okay? So you should be on page 851 with me. There's a great example, those parallel lines. So let's take a look at example 1 that says, the Eiffel Tower shown is in Paris, France. Describe whether any of the sides in the quadrilateral outlined in green are parallel. So you are looking at the green part in the middle of the Eiffel Tower in that picture. And the top and bottom sides of the quadrilateral are parallel. They run the same distance apart the whole way. A quadrilateral with exactly 1 pair of parallel sides is a trapezoid. So that green shape that they outlined, that's a trapezoid because it has 1 set of parallel lines, okay? So some quadrilaterals have both pairs of opposite sides parallel. Those quadrilaterals are called parallelograms. Parallelograms have the attributes shown in the table below. So I'm looking at the picture of the parallelogram, and it says both pairs of opposite sides are parallel. Opposite sides have the same length. Opposite angles are the same size. So if that's true, okay, then they're saying that this is a parallelogram. Let me see if I can draw this. This is a parallelogram. Not the best, but, well, let me redo that. Sorry, guys. This is a parallelogram, okay? This side and this side, so here and here, that's 1 set of parallel lines, okay? And here is another set of parallel lines, okay? Now, that's one reason that it's a parallelogram. The opposite sides have the same length. Well, this should, but you know how I draw. So look at the picture in your book. The top and the bottom are the same length, and both sides are the same length. That's another reason that it's a parallelogram. Okay? Opposite angles are the same size. Opposite angles mean we're looking at this one and this one. Okay? We're looking at here and here. Those are both greater than 90, and they are the same size. And then we're looking here and here. Those are both less than 90, or a right triangle, and so those are the same size. Okay? All right, let's keep moving on to page 852. And we are going to look at the figures in 852. I just want you to take a moment and I just want you to read over that page. This is where we're going to pick up tomorrow because I'm afraid that we're going to get a little too ahead of ourselves. So when we come together tomorrow, I want you to have read page 852 on your own. And the only work you're going to have to do today is some work that I give you on a Google Doc. Okay? So you'll pull that Google Doc up and then you'll submit it online. All right? Have a great day, guys. Good job.